Hello everyone, welcome back to our channel Problematical. Let's discuss exercise 1.3 from chapter 1 sets, maths, class 11th NCERT. First question states, make correct statements by filling the symbols with subset or not a subset in the blank spaces. The dotted part is the blank spaces. In the first part, the set is 2, 3, 4. Dash 1, 2, 3, 4, 5. Now, to be able to place a subset symbol over here, all the elements of your left hand side should be present on your right hand side. So, check. 2 is present on the left hand side, 2 is present on the right hand side, 3, 3, 4, 4. That's why we can say that this is a subset. Second, A, B, C, B, C, D. A is not present over here. B and C are present, but A is not present on the right hand side. So we will not call it as a subset. Here, your X is a student of class 9th of your school. On the right hand, X is a student of your school. We know that the left hand side, all the students of class 11th will also be the students of your school. So we can say that here set A is a subset of set B. Set A being a set of students of class 11th of your school, and set B a set of students of your school. Fourth, X is a circle in a plane, and X is a circle in the same plane with radius 1 unit. Now we know that there can be infinite circles in both the scenarios because on a plane you can have infinite circles. Now right hand side has a restriction that a circle is supposed to be of 1 unit only. But left hand side there will be many circles. There would be some circles which are not of unit 1, but they lie in the same plane on the left hand side. Such circles will not be present in the right hand side. So here your A is not a subset of B. So not all circles in a plane will be present in a set of circles in the same plane with radius 1 unit. Fifth, X is a triangle in a plane and X is a rectangle in a plane. Now a set of triangle is very different from a set of rectangle such that they do not have anything in common. Because if we consider one element of a set of triangle in a plane. So if you look something like triangle ABC, triangle A1, B1, C1. So these would be the names of triangles present in the plane. No triangle is equals to a rectangle. That's for sure. They are not equal. No triangle is equal to a rectangle. So no element of the left hand side will be present on the right hand side, which is a set of rectangles. This triangle ABC could nowhere be found on the right hand side set. Hence, it is not a subset. Next, sixth, X is an equilateral triangle in a plane, and on the right hand side, X is a triangle in the same plane. We know that all equilateral triangles are triangles. So all the elements which are present on the left hand side are present on the right hand side. Hence, A is a subset of B. Seventh, X is an even natural number and X is an integer. Now, all natural numbers are integers. So all even natural numbers will also be integers. Hence, A is a subset of B. Next question. Examine whether the following statements are true or false. First, A, B is not a subset of B, C, A. A is present on left hand side and right hand side. B is present on left hand side and right hand side. All the elements of left hand side, which are two elements A and B, are present on the right hand side. So by logic, A, B, set of A, B is a subset of B, A, C, but it is given that it is not a subset. So the given statement is false. The reason being, they are subsets, or each element of set A comma B. You need not write the word set because the curly braces and the notation itself states that it is a set of set A comma B are present in set B comma C comma E. E is a subset of X such that X is a vowel in English alphabet. So if you convert the set builder form of right hand side in roster form, you can get something like this is the statement. All the vowels in English language, A, E, I, O, Q. So here A and E elements on the left hand side are present on right hand side. Hence the statement is true. 1, 2, 3 is a subset of 1, 3, 5. To be a subset, all elements on the left hand side should be present on right hand side. 2 belongs to left hand side, which is not present on right hand side. Hence the statement is false. Fourth, A is a subset of ABC. A is present on the left hand side, which is also present on the right hand side. Definition of subset is satisfied. Hence this is a true statement. Fifth, set of A belongs to set of ABC. Now we know that with the symbol belongs to, we should have an element on the left hand side and a set name on the right hand side. So with this, you have, if you write belongs to A, comma B, comma C, left hand side should be considered as an element. Now it is written in curly braces and we know that it is a set. So let's give it a name. Let us consider E. A, comma B, comma C. So if you consider this as an element, then this element should be present in the set. Now this is not true, hence this is false. See, instead of right hand side, you would have been given something like this. E belongs to A, comma capital E, comma B, comma C. Then this E, we know that it is a set, but it is a variable. It is an element for this particular belongs to symbol. And it is present in a set on the right hand side as an element. Hence, here the statement would have been true. But here, since this is given, hence the statement is false. Next. X is an even number and less than 6, even natural number which is less than 6. Let's convert it into roster form. Even natural number starts with 1, even numbers are 2, 4 and 6. But less than 6 means we are not supposed to include 6. So it is 2, 4 and subset of X is a natural number which divides 36. Now which numbers divide 36? You have 1, 2, 3, 4. 4 into 9 is 36, 3 into 12, 2 into 18, 1 into 36. Any other? 6. 6 into 6, 36. So these can be written here. 1, 2, 3, 4, 6, 9, 12, 18, 36. 2 and 4. 2 and 4. All the elements of left hand side are present on the right hand side. Hence, you can say that this is true. Next. Let A be a set of 4 elements. Observe A is equals to 1, 2, 3, 4, 5. This is your first element. Second element, from this comma and this comma, here a set is mentioned, but it will only be considered as one element, and this is the one element. So there are 4 elements in A. To avoid any confusion, we recommend to give this set a variable. So let capital B be equals to 3, 4. So you can rewrite the set A as 1, 2, B, 5. Now what we'll do is, we will substitute B in place of 3, 4 in every of the parts of the question and then solve them. Which of the following statements are incorrect and why? Now, the reason of the incorrect statements are also to be mentioned. First, 3, 4 is a subset of A. 3, 4 is being replaced by B. So, B is a subset of A. Now, for subset, you should have a set on the left-hand side and a set on the right-hand side. B is a set of elements 3 and 4. A is a set of elements 1, 2, B, and 5. Now, are these elements 3 and 4 present here as elements? No, they are not present over here. So, elements of B are not present in A. That's why this is incorrect. Now, whenever your statement is incorrect, you're supposed to justify it. The reason being 3 belongs to B. 3 belongs to B. But 3 does not belong to A. Similarly, 4 belongs to B, but 4 does not belong to A. That is the justification. Second, 3, 4 belongs to A. We'll rewrite this as B belongs to A. Now, belongs to means the left-hand side should be considered as an element and right-hand side as a set. So, is B an element of A? Amongst A, is B an element? That's true. So, this statement is correct. Next, set of 3, 4. So, set of B is a subset of A. Now, let's consider this set of B. B equals to C. So, this can be D to avoid confusion. Equals to D. So, this can be rewritten as D is a subset of A, which means this is a set and this is a set. Elements of D should be present in A. Elements of D is this. Elements of D is B, and B is an element of A. So, elements of D should be present in A. B is present in A. So, the statement is correct. Next, 1 belongs to A. And element 1 is belonging to a set A. This is true. Correct. Next, fifth. 1 is a subset of A. Now, to be a subset, your left-hand side should be a set. It is an element, so it is incorrect. Which reason can you state? Because element of set can never be a subset of itself. Element 1 is an element of a set. Element of a set, that is 1, cannot be a subset of itself. Sixth, sorry about this. Yeah. Sixth part is 1, 2, 5 is a subset of A. One, 2, 5 subset of A. So what does this mean? Your E is given as 1, 2, B, 5. 1 is present over here, 2 is present over here, and 5 is present over here. So this is a true statement, correct? Seventh, 1, 2, 5 belongs to A. Now this is a set. The whole set of 1 to 5 is not an element of A. Because you should have an element over here. The whole set, if you represent 1 to 5 by E, 1, 2, 5 by E, then you're saying that E belongs to A, which is not true. So the statement is false. 1, 2, 3 is a subset of A. 1 and 2 are belonging to a set A, but 3 is not an element of A. B is an element of A, but 3 itself, this number 3 is not a separate element of A. So this statement is also false. 5 is a subset of A, it belongs to A. 5 belongs to every set. So this is universally true. Phi is a subset of A. Phi set contains no elements, and that no element is not present in A. So your 10th statement. Okay, hold on. Phi is a set, and you should not have. Sorry. Phi always belongs to A, but phi can never be a subset of A. So let's write the 7th and 8th first. 1 to 5 and 1 to 3. 1, 2, 3. Subset of A. Your 3 does not belong to A. Hence, this is incorrect. Next. This statement 1 to 5 belongs to A. This is your 8th part. Your 7th part is 1, 2, 5 belongs to A. Now, this is, we have considered this to be 1, 2, 5 to be set E. And your given question can be transformed as E belongs to E. Now we know that A is 1, 2, B and 5. So E is not an element of A. Hence the statement is incorrect. What can you say for reasoning? That 1 to 5, because 1, 2, 5, this whole thing, that is is not an element of A. Ninth. Now phi and E. We know that phi is a null set. So null set will always be a subset of any set. I said belongs to, which is incorrect. The null set is always a subset of any set. But null set does not belong to A because A has only 4 elements 1, 2, B and 5. It does not have phi. If you had something like F is a set, it had elements like 1, 2, B, 5 and G. And G is phi or G is a null set. Then you would have said that that phi belongs to F. The 9th statement says that phi belongs to F belongs to A. So phi is not an element of A over here. That's why the statement is incorrect. Reason being, since phi is not an element of A. Hence, phi is a subset of A. This is universally true. It's a correct statement. Set of phi is a subset of A. Set of phi is a subset of A. Again, a set which has phi as its element is a subset of A only when phi, this element of the set, which is phi, should be an element of A. We know that phi is not an element of A. So this is incorrect. And it's the same reason, since phi is not an element of A. Next, write down all the subsets of the following sets. So you're supposed to write all the subsets. First part, we know that phi is a subset of any set. Phi is a subset of A. And second, A itself is a subset of A. Second, A is a subset of A comma B. B is a subset of A comma B. phi is a subset of a comma b, and a comma b itself is a subset of a comma b. Good. You have three elements, so there would be three singleton sets, two sets with two elements each, one set with phi, where phi is a subset, and one where the complete set is a subset of itself. So phi, the subset would be phi 1, 2, 3, 2 comma 3, 1 comma 2, and 1 comma 3. Apart from this, the set itself 1 to 3 is a subset of itself. Phi is a subset of itself. Next, how many elements has power set of A if A is equals to 5? Now, if A is equals to 5, if A is equals to 5, we just saw that phi is a subset of itself. Also, A will have 0 elements, so n of A will be equals to 0 if A is equals to 5. By definition, we know that if your number of elements and power set of A, power set of A has 2 to the power elements, which will be the number of elements of A. So 2 to the power 0 in this case. If you have n elements, your power set of A will have 2 to the power n elements. Therefore, this is equals to 1. Power set of A is equals to 1. Also, phi is a subset of itself. So how many elements does P of A has? P of A has only one element, which is equals to phi. Next, write the following as intervals. Intervals means you have to imagine a number line. You mentioned that R, x belongs to R. It's a rational number. It's a real number. And minus 4 less than x less than equals to 6. So if you consider minus 4 over here, 6 over here, your numbers are lying between minus 4 to 4, including 6, because it's less than equals to 6, including 6 and excluding 4. So this would be, write the following intervals. Your first part would look something like round bracket minus 4, comma 6, square bracket. Square bracket states that that particular element is involved and round bracket element is not involved. X is a set of all x such that x belongs to real number. Minus 12 less than x less than minus 10. So minus 12 less than 10 less than minus 10. So x is lying between this. But we cannot include either of these two. Both are hollow. It is round bracket minus 12, comma, minus 10. Similarly, for the third part, 0 less than equals to x less than 7. So 0 is included. 0 is included means 0 should be in square bracket. And 7 is not included, round bracket. Fourth, 3 less than equals to x less than equals to 4. So you have 3, comma 4, both side square brackets. If you were to draw them on the number line, they would look something like this. 0, 7, 3, 4. The values within them are included. Here you have hollow, here you have fill, fill circle, fill circle. Next, write the following intervals in set builder form. Earlier, set builder form was given to you, and you had to write them in interval form. Here, the intervals are given to you. You have to write them in set builder form. So, your minus 3, 0 can be written as a set of all x such that x belongs to R and minus 3 less than x less than 0. Second, box 6, 12 is a set of all x such that x belongs to R, 6 less than equals to x less than equals to 12. Third, round bracket 6, 12 means set of all x such that x belongs to R, 6 less than x less than equals to 12. And fourth, minus 23, 5 round bracket is equals to x such that x belongs to R, minus 23 less than equals to x less than 5. What universal sets would you propose for each of the following? Now, U is a set. Universal set is that set which should contain all the elements of the set. If you consider A to be a set of right triangles, right triangles means at least one of the three angles should be equal to 90 degrees. If one of the angle is 90 degrees, the other two will always be less than 90 degrees, and they will be acute angles. So a set of right triangles. There are infinite triangles in the universe, so you can consider right triangles to be part of those infinite triangles. Universal set can be considered as set of all triangles. The second part is set of isolated triangles. You can use the same universal set for set of isosceles triangle. Isosceles triangles are triangles with whose angles are same, whose two angles are equal. These are isosceles triangles. Next, given the set A, this, and this, which of the following may be considered as a universal set for all the three sets A, B, C? So the easiest way to do is write a universal set of your own considering the values of A, B, and C. So you should contain all the elements of A, B, and C, so write them together. A contains 135, 135. B contains 246, so 246 should be there. What else should be there? 0, 2, 4, 6. Now 0 should be there. We included 2, 4, 6 already, so we will not rewrite them, and 8 is included. By writing them in a proper fashion, like ascending order, 0, 1, 2, 3, 4, 5, 6, and 8. So any set amongst these four, which contains all these elements, at least all these elements, will be considered as a universal set. First, 0, 1, 2, 3, 4, 5, 6. It does not contain 8, which is required. So this is not universal set. 5, definitely not. We need these elements. 1, 2, 0, 1, 2, 3, 4, 5, 6, and 8. All are covered. Apart from that, you have additional elements. We need not care about it. So this can be considered as a universal set. The fourth part does not contain 0, which is required in your universal set, which is based on the given question. So this is not a universal set. Your correct answer would be 3 because it contains all the elements which are present in A, B, and C. Or you can say that A is a subset of U, B is a subset of U, and C is a subset of U for U is equals to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is your third part. So this concludes this exercise. We'll continue on the next class. Thank you.